Hi, we are in the La Silla Observatory in Chile at 2,400 meters above the sea in the Chilean Andes. In my back we have the Euler telescope. Now we are going to talk to the astronomer who is operating the telescope, and he will teach us how the telescope works and what are the chances for this little telescope here in Chile to find some extrasolar planets. Can you join me, please?
Sí, siga nomás. Ya.
Hi, how are you?
Fine, and you?
Oh, I came here to talk to you and ask you some questions about the extrasolar planet.
Yes, of course. Come in.
Thank you. Okay, so can you tell us where we are, which telescope are we, and what is the main purpose of the telescope?
Okay, so hello. We are here in La Silla Observatory in Chile, and we're in the control room of the Swiss telescope. The name of the telescope is Euler, and here we look for exoplanets orbiting other stars than our sun.
So can you show us explain a little bit what the computers here are doing, please? And can you get the microphone close to you? Yeah, that's okay. Okay, now you count 3 and you answer the question, please.
Okay, so here are the control screen of the telescope. So on the top left we have the real control of the telescope. We can stop the telescope, start the telescope if we want. Here it's the control, so here we can prepare our night. So the whole observations, we are going to put them here in one after the other, and when the observation of one star is finished, it will automatically pass to the next one. And here we can see the whole night with the hours. And actually there is the moon here rises, so we can see everything, and our observations will show here when we put them. So yeah, that's how we control the telescope and the instruments that are on it.
Okay, now please can you tell us a little bit about, very shortly, the history, how the extrasolar planets were found, the first one, who did, and how, if you are involved with that team.
Yes.
And what now this team is doing, and what you're expecting about the planets. Okay.
Okay, so the history, actually the first exoplanets has been discovered by the team of Michel Mayor in Geneva. It's the same team I'm working on, and it's been 19 years since the first exoplanet has been found. The name of the first exoplanets was 51 Pegasi b, and it was a really strange planet to find, because it's a giant planet like Jupiter, but really close from its stars. So we didn't think before that this kind of planets could exist, and it was also really important to find this kind of planets, and since that we discovered a lot of these kind of exoplanets. So here it's a telescope to do the same kind of research that has been done to find the first exoplanets, and we're doing it since 19 years in this group, and we expanded this research to a lot of different parts. We now try to find some data of the atmosphere of exoplanets. We try to find lower mass, like Earth mass exoplanets, and further from its star, so maybe trying to find it in the habitable zone. And yeah, so it became really a huge field of research. Now, since 19 years, there has been more than 1,500 exoplanets that has been found. And so, yeah, it's really crazy how it evolved in only 19 years.
What do you think? What are the chances for to find an Earth-like planet, and what that will mean for science and for humanity?
Okay, so there is two things. The first, that an Earth-sized planet there has been already a few that has been found, but not in the habitable zone. The habitable zone is a zone that is where there can be some water on the planet. That's important to find some life on the planet. So the Earth is perfectly inside the habitable zone. So since a few years now, we have found a few planets that are the same size of the Earth, but it's hard to find them in the habitable zone because it's far from the star. And the more we go outside of the solar system, I mean the star system that we found in the exoplanets, so the more we go further from the star, the harder it's to find the planet. And now, so it is the purpose, I mean, one of the purpose to continue this kind of research, to find a planet similar from the Earth. So we are trying hard, and the chances are really high. Probably in a few years we will be able to do that with a new instrument that are being built right now. Actually, there is one spectrograph really high precision, like the ARPS one that is here in La Silla in the 3.6 meter telescope. There is one also really high precision spectrograph that has been built right now, and it's going to go to the VLT, the Very Large Telescope in Mount Paranal, and so that's going to be for a few years, and we hope to find planets the same as the Earth in a few years from now.
Okay, go ahead.
Okay, so here is the Swiss telescope. It's red as the Swiss flag. And here you can see the camera. Actually, it's a huge camera, and there is also all the instrument to make it cool down, because to have nice images we need to cool the detector a lot. So there is here the tube to bring some liquid nitrogen inside the camera, and so the whole thing here is the camera of the Swiss telescope.
What does this instrument, what is it doing to that?
It's really a camera, so it does images. We use it to do some photometry and also some image of cosmic some gravitational lenses. It's when you have a really high mass corpse, if you want, like a galaxy or something like that, and you have another one further behind, then the light will be bent by the gravitational potential of the galaxy, and it will be bent and then come back to us, and so it's called gravitational lenses, and we do observations of that with this camera. The other instrument of the telescope is this instrument. It's a spectrograph. Its name is Coralie. 1, 2, 3. So here we have the Coralie, the spectrograph of the other telescope, and this is the instrument with which we observe exoplanets and try to find them. The spectrograph does actually the same as a rainbow. It separates the different colors of the light, but really widely, and so we can observe the absorptions line of the star, and when there is a planet that goes around the star will also move around the center of mass, and these lines will go from the blue to the red, and the blue again, and the red, as the star comes towards us and go further from us. And so that's the instrument that does this spectral, and with which we can detect some exoplanets. Okay, so here we have the instrument named PISCO. It's actually another small telescope that is attached to the bigger one, and with that we can do some photometry, so some to look at the intensity of the light of stars in the same time as we use the spectrograph Coralie, so we have more information about the stars, and we can be more precise, or just do some other science to use the both instruments at the same time. So that's why we have this small telescope attached to the bigger one.